All right, so now we're ready to talk about how plate tectonics actually works as we understand it today. So we'll look at plate tectonics through a series of videos, but this first one is going to focus on what happens when plates diverge. This is going to pick up on some of the ideas that we were talking about seafloor spreading. And so when you're reviewing this material, make sure you can distinguish between convergent, divergent, and transform plate margins. Also make sure you can describe how new ocean basins can form from continents. So the last really essential piece of evidence that we haven't talked about yet is this geography of earthquakes that was observed over the 20th century. These are all the earthquakes measured globally between 1900 and 2020. Each is marked with a star, but the magnitude here is shown by really larger and larger stars, and also the depth that those earthquakes take place is marked in a color here. So you can see that, for instance, the margins of South America have really deep earthquakes that are large, same with Japan. But you also see the mid-ocean ridge system having largely shallow earthquakes. So the location of these earthquakes correspond almost identically to the borders of what we now know are lithospheric plates. The idea of a lithospheric plate comes out of the original formulation of plate tectonics by J. Tuzo Wilson in 1965. This original theory has been added by so many earth scientists over the last several decades. This is now really a mainstream theory about how the Earth works on its surface and how it regulates things like heat flow, things like elemental cycles. This is really one of the central tenets of modern geology. So what is plate tectonics actually? The central proposition of plate tectonics is that Earth's surface is broken up into 7 major lithospheric plates. There's the Pacific plate, Australian plate, the Eurasian plate, the North American plate, the South American plate, the African plate, and the Antarctic plate. So these are the major pieces of Earth's surface. They're all separated. You can see the mid-ocean ridges are a boundary in plates. You can see that ocean trenches are a boundary in plates. And then in between some of the major plates are the more minor plates, things like the Philippines plate, things like the Cocos plate, the Caribbean plate, the Nazca plate. There's a lot of smaller microplates around the world too that are often ignored, but they play an essential part in this global cycle as well. And so these different sections of the lithosphere, they float on top of the oceanosphere, but they change over time at certain boundaries. So when one plate meets another plate, there's a couple different things that can happen. These meetings between plates are called margins, and these plates can either separate from one another at a divergent margin. That's where one plate is pulling away from another plate. This is common in things like ocean ridges, and this is also how new oceanic crust is created. There are also convergent margins. One plate is colliding towards another plate. There's a head-on collision, and this usually leads to one plate being subducted underneath the other plate. This subduction zone process is really essential to generation of things like continental crust, but it also generates a lot of volcanic hazards that we have today. And this is one of the main processes that destroys oceanic crust. And then finally, there's a third type of margin. It's the conservative or transform margin. Essentially, these are plates sliding past each other. There's a lot of friction stored here, so this is an important way to generate earthquakes, but there's no crust being created or destroyed in this process. So overall, Earth's size is constant, so the production of new plates has to be balanced by the destruction of old plates, or vice versa. New plate destruction has to be balanced by creation of new plates. So let's first start with the divergent boundaries, and we'll split this into the types of boundaries that are the types of plates that are separating. For the oceanic-oceanic divergent boundary, this is the same thing as seafloor spreading that we've talked about already. This is happening in the mid-ocean ridge system here. As plates are being pulled apart, magma from the oceanosphere is coming up, and it's melting due to decompression. So the high pressure in the mantle is the main thing that's holding the mantle in a solid state. Once that pressure is relieved as the plates depart, then you can form magma. That magma rushes up, it forms new crust, creates conditions for hydrothermal vents. So this is found throughout the mid-ocean ridge system, such as the East Pacific Rise and the Mid-Atlantic ridges. This process generates lots of shallow earthquakes and lots of small volcanoes, and then, like I said, supports hydrothermal vents. So divergent boundaries can also happen on land, and this is a bit more rare in the modern day than mid-ocean ridge systems, but it's still quite important. So this is a continental-continental divergent boundary. The steps here are a bit more complicated. Essentially, we need to have a new magma source from the mantle coming up and beginning to weaken some part of the continental crust. The presence of this heat causes the topography to swell and crack, and this creates fissures in Earth's surface. Eventually, the weakening of this part of the crust and the spreading of the plate apart to the left and to the right creates what's known as a rift valley here. So this is an area, this is a local depression. What happens often is that water from rain comes in, pools here, and forms these really long, narrow lakes. So this process keeps happening. These plates keep pulling, the left part of the plate and the right part of the plate keep pulling apart. And eventually what's happened is that this magma can now come in and form new ocean crust directly. So this creates a new spreading center, a new oceanic-oceanic spreading center in the center in this narrow sea. Think of something like the Red Sea where this process is actively happening. But if this keeps going, this can create an ocean basin. And this is how we think Pangaea broke apart. So a magma source came in, it helped weaken the crust. The crust is being pulled to the left and pulled to the right, and then this new ocean basin was allowed to come in. So the main place this is happening today is on the border of the Red Sea and East Africa. So you can see this is oceanic crust in the Red Sea. This is the spreading center here. And then there's this area of thinning crust sort of moving in the Ethiopia region sort of into the Rift Valley of Africa. You can see there are these sort of long series of rifts that are mostly filled with water here. This is where the Earth is being pulled apart. You have one piece of crust moving to the right, one moving to the left, and then that's creating these rift valleys that will hold water and then eventually become new oceanic crusts. So you can see some examples of this heat source weakening and fracturing the land here. This is in Kenya, where there's a road here that's been basically split apart by a new fissure in the earth. I'm just going to skip ahead a little bit. But you can see these, the soil is being pulled apart. They have to build new part of the road in order to have traffic go along. And this extends, for hundreds and hundreds of feet. So this is happening, periodically in places like East Africa. During the breakup of Pangaea, this is happening sort of throughout the entire Atlantic. Okay, so in this video we started talking about plate tectonics and focused mostly on diverging plates. So diverging plates are when two plates are moving apart from one another. This creates an opportunity for new oceanic crust to form, whether that's an ocean-ocean divergence that happens in mid-ocean ridges, or it's a continent-continent divergence that forms rift valleys and then forms new ocean crust. And so that's really how ocean basins can form from continents. You weaken the continent, they spread apart, and then eventually new magma comes up and that forms new basalt, new ocean floor.